Welcome to Edubbey Global Solution, and in our mathematics class we're going to be looking at another topic, which is angles properties. Under this class we have different properties of angles that we are going to be highlighting with examples and past questions related to each of the properties. We have an interactive content here that will serve as a guide even for this class. Okay, now first and foremost, the very first one we're going to be looking at is angle at a point and on a line. And how do we go about this? The best way is for us to look at revolution, half revolution and complete revolution. Okay, so one complete revolution is equivalent to a rotation of 360 degrees about a point, and half a complete revolution is equivalent to a rotation of 180 degrees about a point. The fact can be clearly seen by looking at a circular angle or a semicircle protractor, and that is what we're going to be looking at. Now let's assume that we want to sketch a circle to indicate a complete revolution. So we have this point here and we are rotating like this. This is a complete revolution, right? And now for us to have an half revolution here, that implies that we divide our complete cycle into two. So half here is going to give us 180 degrees, half here is going to give us 180 degrees, and the additions of two give us 360 degrees, which makes a complete revolution. And we can use an example of our protractor, the mathematical set protractor that we have here. Look at this illustration here. This is more or less like we are having, look, if you divide this now, the upper part here is a semicircle protractor, and the lower part here as well is a semicircle protractor. Okay, now let's look at an example related to this. We say that for angle on a point, we have this diagram here. We have 170 degree here, we have 120 degree here, we have S degree here. So, and if you look at this rotation, this is more or less like a complete revolution, which is what? Which is 360 degree. So we are going to be calculating the angle of X by equating the sum of all these degrees to 360 degree. So having that one, by the time we rotate, we add up 120 degree to 170 degree, then we subtract from 360 to give us the value of X. So we have that to be what? 360 degree equals to X degree plus we have 120 degree plus 170 degree. Okay, so we have 360 plus what is 1 equals to rather S degree, 120 degree plus 170 degree, that give us what? That's 290 degree. We want to get X, so we take 290 degree to the other side. We have 360 degree minus 290 degree equals X. Okay, now 360 minus 290 degree, what's that? That's going to give us what? 70. So 70 degree equals X. So X in this diagram is taken as 70 degree, and that makes this what? This diagram here a complete revolution. Now let's put the right answer in our boxes and let's see what we have. We already made the arrangement. So by bringing 120 and 170 to the other side, it changes from plus to minus, and what is missing here is what? 170 degree. So 120 minus 120 degree minus 170 degree, that will give us what? Minus 290 degree. 290 degree, 360 minus 290 degree, that will give us what? X will give us what? Give us 70 degree. Let's check. Okay, that's our arrangement, and our arrangement is cool. Now the next property here that we want to look at is what? Angle at a point on a straight line. The sum of the angle at a point on the straight line is 180 degrees. This is more or less like you are dividing your circle into two to have a semicircle, right? Or semicircular protractor, for example. So the upper part of that circle is 180, the lower part is 180, and this makes angle on a point on a straight line to be what? 180 degrees. Now let's look at the activity that we have here, and let's sort out the solution. We have to calculate a degree from that diagram. If you look at this diagram, this is an angle on the straight line. We have 40 degree, 88 degree, 8 degree, and 25 degrees. So we need to calculate 8 degree. We've told us that the sum of angle on the straight line is what? is 180 degrees. So that implies that we are adding up all this angle on this straight line and we are equating it to what? 180 degrees to get A. So we have 40, okay, plus 88 degree plus A degree plus 25 degree. So if that is it, 180 degree equals to 40 plus 88 plus 25 will give us 153 degree. Remember, we still have our A degree here. So we bring 153 to the other side and it changes to minus. So we have A 180 degree minus 153 degree equals A. So 180 degree minus 153 degree. By the time you subtract 153 from 180, our answer is going to be 27 degree. So A degree here is going to be 27 degrees. So by the time you add all of this together, we have to add 180 degree, which is the sum of angle on a straight line. Now let's put the right answer in these boxes that we have here. Okay, we break the arrangement already. So we have wow, what is missing here? I think A is missing because it is A that we are needed to calculate here. Okay, so minus 1/4 minus 40 minus 88 minus 25 will give us what? Minus 153. Okay, now if you subtract 153 from 180 degree, you are going to have 27 degree, which is what? Which is A. Okay, now let's check our arrangement is full. Now let's look at this activity here. Now, semicircle protractor is an illustration of a complete revolution. The semicircle protractor is an illustration of a complete revolution or a half complete revolution. It is an illustration of a half of a complete revolution. So this is false. Circle is an illustration of a complete revolution. Now, okay, let's look at this. Okay, one complete revolution is equivalent to a rotation of 360 about a point. Yes, by the time you rotate a circle from the starting point, it gives what? 360 degree. Okay, now let's look at another property of an angle, which is what? Angle formed within parallel lines. When two straight lines crosses, it is found that the angle opposite each other are the same size. Okay, they are known as vertical opposite angles. Note that angles at a point on the straight line is added up to what? To a 180 degree. We made mention of that earlier in this previous slide rather. So what we are talking about here is that for a parallel line, if you have two parallel lines crossing each other, their angles are the same. So we refer to this as a vertical opposite angle. So for this type of illustration here, if you look at it, we have A, B, and C. So if you are, based on the property that we just made mention of now, we can now say that angle A is the same thing as what? Angle C. So that is their vertically opposite each other. Okay, and by the time you add angle A plus B will give us 180. That is what? A sum of angle on a straight line, right? And angle B plus C also will give us what? 180. If you look at this, this is also a sum of angle on a straight line. Now we want to look at another line here, which is what? Which is corresponding angle. When two lines are crossed by another, which we call transversal, the angle in the matched corner are called corresponding angle. So when we have two lines, now look at this example that we have here. This is a line and this is another line. So we have another line which is transversal that is crossing these two lines. So the angle that we have here, which is at the corner, and the angle at the other corner, we call it what? We call it a corresponding angle. So let's fix the right answer into our process. When two lines are crossed by another line, which is what we have it to be transversal, okay, then the angle that is in the corner match is what we call what? We call it a corresponding angle. So if you look at it here, we have angle A here and angle B here. So we call this angle A is corresponded to what? Angle B. That is, angle A here is equals to angle B. So if 5 degrees in A, then B also takes 5 degrees. If B is 60 degrees, then A also takes 60 degrees. Okay? Let's look at alternate angles. Alternate angles are angles that occur on the opposite side of the transversal line and have the same sides. Okay, now let's look at this here now. If you look at what we have here, this is a line, this is another line. We have a transversal line that is crossing these two lines. We've said that the corner match, the angle on the corner match, which is A and B, is what? Is a corresponding angle. Now, for an alternate angle, the angle on the opposite side of the transversal line is what we call alternate angle. So, A is alternated to C here, so they are vertically opposite each other. So, A is an alternate angle to C. So, if A is 70 degrees, definitely C as well is going to be what? 70 degrees, because they are alternate angle. They are vertically opposite each other. Now, let's look at the first question we have here. Look at that. We have a what? We have a two line that is crossed by another line, which is a transversal line. And to give another illustration, and we have a degree here. We have y degree, s degree, and 68 degree. Now, the diagram shows two parallel lines and a straight line that is crossing them, which is a transversal line, right? Now, we have to find the value of x and the value of y. Now, based on the previous explanation of alternate angle, we said that the angle on the opposite sides of that transversal line is what? Is alternate to each other. So, if you want to get the value of y here, y is going to be what? Y is going to be 68 degrees, because if you look at this, let's assume this is z degree. Z degree is vertically opposite y degree, so they are alternate angle, and this make y to be what? 68 degree. Now, after getting y to be 68 degree, now let's get what x is. Based on the properties of angle of on the straight line, we said that the sum of angle on the straight line is what? 180 degrees. So if you look at this, this is an angle. If you look at this, it's on the straight line. And if you look at this as well, this is an angle on the straight line. So we need x and what? We need x and we have 68 degrees. So the sum of that angle is what? The sum of that angle is 180 degrees. So we are equating x degree plus 68 degree equals 180. So with that, we'll be able to get our x degree. We've said that y degree is 68 because it's an alternate angle to this. This is vertically opposite each other. Okay, now for x, that's going to be s plus 68 degree equals 180. Why are we having 180? That's sum of angle on the straight line. So we are bringing 68 to the other side, and it changes to what? Minus. So we have s degree equals to 180 minus 68 degree. What is 180 minus 68? 180 minus 68 will give us 112. So s is going to be what? S is going to be 112 degrees. So assuming that we have 112 here, so x is what? X is 112 degrees. That this is the solution to this past question. This takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class.